Given the Simplex Tableau, determine if an optimal solution has been reached, and if so, give the solution. If not, we're going to find the next pivot element. So, here is a Simplex Tableau. We look at the bottom row down here, and we look for negatives. Well, there aren't any. So an optimal solution has been reached. So we're looking for unit columns. We would like to have all unit columns. Okay, so anything that's not a unit column, we're going to very carefully scratch out. So the column for X is a unit column. Remember, a unit column has 1, 1, and everything else zeros. So we have a unit column for X and for Y. Z is not a unit column. S1 is not a unit column. S2 is not a unit column. So now we're going to list our variables, all of them, even the ones we scratched out. And the ones we scratched out, we're going to assign a value of 0. Okay, so now we're going to go back to our matrix, and we're going to read out the answers. Pretend these columns aren't even in there. So 0x plus 1y plus 0s3 plus 0p is 1. Looks like y is 1. Okay, be very careful. Some of you are probably tempted to put it here, right? But it doesn't go there. It goes here. Even though it's in the first row, it's not the first variable anymore. Okay, now go to the second row. 1x plus 0y plus 0s3 plus 0p equals 2. So it looks like x is 2. Okay, row 3. 0x plus 0y plus 1s3 plus 0p is 2. So s3 is 2. And look at the bottom row. You see you only have one entry that's a 1. So 1p is 6. Okay, so we see that that has exactly one solution, and we found it. Okay, let's try another one. Looking here, this one, has an optimal solution been reached? Well, we see there's no negatives in the bottom row. So again, an optimal solution has been reached. That's awesome. So again, we want unit columns. So anything that's not a unit column, we're going to scratch out. So it looks like Z is not a unit column. Neither is S1, and that's it. So Z gets a value of 0, and S1 gets a value of 0. Now we're going to read off the answers out of the table. So again, pretend these columns aren't even in there. So we have 0x plus 1y plus 1s2 plus 0s3 plus 0p is 1,000. Wait, what? Read it again. 1y plus 1s2 equals 1,000. Let's write it down. Y plus s2 equals 1,000. Some of you are probably tempted to go over here and write y equals 1,000. Can't do that. There are two entries here that are 1. So we have an equation that looks like this. Okay, so let's hold off on that one. We'll come back. Let's do the rest of them. 1x plus 0y plus 0s2 plus 0s3 plus 0p is 240. Whew. Okay, this row has only one entry that's a 1, so we're good to go. X is 240. Write that one down. That one's easy. Okay, row 3. 0, 0, 0, 1, 0, 285. So there's only one entry here that's a 1. So 1s3 is 285. So S3, it's very, very tempting to put it in the wrong spot. S3 is 285. Look at the bottom row. 0, 0, 0, 0, 1, 605. There is only one entry that is a 1. So 1p is 605. So p is 605. Okay, those were easy. So let's go back to the one that was a little bit tougher. So we have y plus s2 equals 1,000. How do we handle that? Well, how did you handle it when you did matrices? Remember, if we're solving a system of equations, we can have exactly one solution, we can have no solutions, or we can have infinitely many. So in this case, we're going to have infinitely many solutions because we are going to pick a variable, either one, the y or the s2. So we're going to look like s2 equals t, remember this? Where t is any real number. Well, how many real numbers are there? Well, there's infinitely many, right? So because t can be infinitely many things, so can s2. So we have infinitely many solutions. S2 is t, and then y right here is 1,000 minus S2. So Y is 1,000 minus T. And again, we see there are infinitely many solutions. Be very careful. Don't just say, oh, there's a 1 there. I know what that constant is. That isn't how it works. Be very careful. Let's try another one. Okay, directions. Let's remind you of the directions. We're going to find an optimal solution if there is one. And if not, we're going to find the next pivot element. Okay. So has an optimal solution been reached here? No. How do we know? Well, there's still negatives down here, right? So our strategy is to look for the most negative. Well, we're in luck. There's only one, right? So this is the pivot column. How do you find the pivot row? Well, remember we take the entry in the constant column and we divide it by the entry in the pivot column. So we do 12 divided by 2, which is 6. And we do 8 divided by 1/2. Do not say that's 4. That's not 4. When we have a number divided by a fraction, we rewrite the top and you multiply by the reciprocal of the bottom, because this is really 1 over 2. So when you multiply by the reciprocal, it's 2 over 1. So this is 16. Which one's smaller? This one. So this is your pivot row. We see this entry here. The intersection of the pivot row and the pivot column is your pivot element. Again, be very, very, very careful. It's very tempting to say that this entry right here is not 16, that it's 4, but you'd be wrong. Be very, very, very careful. Let's try some more. Same directions. Has an optimal solution been reached? If so, give us the answer. If not, find the next pivot element. Okay, has an optimal solution been reached? No. There are still negatives down here. Which one is the most negative? Okay, well the most negative, and again in this case there's only one, that makes it easy. This is your pivot column. Okay, then we do the pivot row. We take the constant entry and divide by the entry in the pivot column. So again, I'm looking here. So 12 divided by 0. Oh crap, we can't do that. Can't divide by 0. That's what killed the dinosaurs. We have to throw out that option. That is not going to be an option for our pivot element. Okay, then we do 64 divided by -2. Uh-oh, did we need a non-negative ratio? Can't use that one either. So it turns out this simplex table has no solution. The process breaks down. We're not able to figure out what the pivot element would be. So there's no solution here. Okay, let's do another one. Has an optimal solution been reached? Well, are there negatives down here? Nope. Okay, so then we're going to keep all of our unit columns because we know an optimal solution has been reached. So we keep the unit columns. Anything that's not a unit column, we scratch it out. Scratch it out. Scratch it out. Okay, so Z is 0. Looks like S2 is 0 and S3 is 0. Okay. So then we go line by line. First row, there is 1, 1, and ignore the stuff I've scratched out. 0, 0, 0, and a number. Okay, good. A little gun shy from before. So 1x is 30. So I can start at 30 here. Okay. Row 2. Looks like I have 0, 1, 0, 0, and a number. 1y is 10. So y is 10. Easy peasy. Row 3, 0, 0, 1, 0, and a number. Okay, good. So it looks like 1s1 is 10. Last row, 0, 0, 0, 1, and a number. Okay, only have one entry that has a 1 in it. So 1p is 60. P is 60, and we're done. We have exactly one solution, and here it is. Now keep in mind, obviously this problem was given to you just in the simplex table. You don't know where it came from. But when we have a slack variable equal to a number, that means there was something left over if this pertained to a real world situation. Okay, so often that means you have some leftovers of some sort. Okay, one more. Has an optimal solution been reached? Nope, there's negatives down here, right? So we pick the most negative entry. Okay, the most negative entry is -8, right? And when I say most negative, remember, that's the one that if you were to put all these numbers on a number line, that's the one that would be the furthest to the left. Okay, so we have the most negative entry there. So we label this whole column. The X column is the pivot column. And then we take the entry in the constant column and divide by the entry in the pivot column. So 0 divided by 1. Remember, I'm looking here. That's 0. Then we have 350 divided by 5. What's that? 70. And then we have 100 divided by 20. And that's 5. Okay, so we want the smallest non-negative. Which of those is the smallest non-negative? Well, most of my students would say this one, and they'd be wrong. We want the smallest non-negative. Non-negative. We classify numbers 3 ways according to sign: positive, 0, and negative. Okay, so if we want non-negative, that means we want 0 and we want positive. So this guy is the smallest. This is your pivot row right here. Here's your pivot column. So that's your pivot entry. Okay, be very, very, very careful. Smallest non-negative. 0's allowed. 0's allowed on top, right? Because earlier we threw out a ratio with 0 on the bottom. Look up here. So I'm allowed to have 0 on the top, not on the bottom.